Hello everyone, welcome back to channel. So in today's video, we are going to discuss about the equilibrium, and the problem mostly asked in the equilibrium chapter is sphere related problems. So we'll understand this topic. So basically there are two types of reaction. One is called as an external reaction and one is called as an internal reaction. So internal reactions are one which happens because of the contact surface between the two spheres. So here say the sphere A is in contact with the sphere B. So this contact is called as an internal contact. So reaction which occurs because of this contacts are called as internal reactions. Whereas when there is a contact between the sphere and a wall or sphere and a wall, the reactions are called as external reactions. So first we'll see what is the question. Two spheres A and B are kept in a horizontal channel. Determine the reactions coming from all the contact surfaces. Consider the radius of A and B are 40 mm and 30 mm respectively. Take WA 500 Newton, WB is equal to 200 Newton. So here the radius and the weight value for the sphere A and B are given. First find out point of contact. So if you see sphere A, it is in contact with the wall at this point, as well as the sphere A is in contact with the ground at this point. Sphere B is in contact with the wall at this point. So these 3 points are called as a external reaction or external point, whereas sphere A and B are in contact at this point. So we'll call this as point internal contact, or it is called as an internal reaction point. So here we'll give the name. So we'll identify here. So as this is the contact, we'll call this as point 1. This point we'll name it as point number 2. This is point number 3, and or this is 3. We'll call this as point number 4. So there are 4 contacts: 1, 2, 3, and 4. So we'll see how we can show the reactions here. Now we have the reaction force here. Okay. So first show the reaction force in this way. Okay, draw the line. This line should be perpendicular to this surface in contact. This is the surface in contact. It is vertical, so reaction force will be horizontal. So this is your reaction, and always this reaction force will pass through the center of the sphere. Okay, and the name of the reaction will be R. Just a minute. R. Name of the point. Name of the point is 1. So we'll call this as R1. Getting? Always show this arrow towards the center. Then the second point of contact is here. Okay, so for this we can draw the line which is perpendicular to the surface in contact. Now this is the surface in contact. This surface is horizontal, so reaction force must be vertical. Show the arrow. The arrow must be pointed toward the center and passing through the center. Okay, so this way we can show this reaction force 1, and this is the reaction force 2. So this is your R2. Clear? So we'll show the reaction force. To draw the reaction force, draw a line which is perpendicular to the surface. So this is the surface and perpendicular to it. Now show the arrow towards the center, towards the point B, and this should pass through the center of the circle, right? So we'll give this name as R4. Clear? So this way first show the external reaction, then we'll show the internal reaction. So for that, just we have to connect the centers of the sphere. So this is center A, this is center B. Connect it. Now we'll show the reaction force. How we show the reaction force? The reaction force, we just increase the thickness of this line. So this reaction force is always towards the center, right? And one more reaction we have got here. Show the arrows to them. So this arrow should be pointed toward the center of the circle, right? Always, because always remember tension is outward force and reaction is an inward force. So we'll give the name here. The name of this point reaction is R3, and this one is R3. So these are the internal reactions. So this R3 and R3, they are equal in magnitude but opposite in direction. So they balance each other. Okay. So that's why they maintain an equilibrium. So what is equilibrium? The resultant forces and the resultant moment acting on any objects are zero. Then only we call that object is in equilibrium. So here we have drawn the forces acting on this body. One more thing remaining is that the weight force. So we'll show the weight force. How we show the weight force? It always acts from the center of the sphere and acting in the downward direction. So this is the weight force, act in the vertically downward direction. What are the values of weight force given? So here the weight force at 1 or A is 500 Newton. So the value of weight force is 500 Newton here, and the value of weight force here is 200 Newton. This way we have shown all the forces acting on the body. Okay. Now one more thing is remaining here, to find out the angle of the R3 with the horizontal. So this angle is very important. So consider this triangle. This is point A, this is point B, and we'll call this as point C. So here we got this triangle here, right? So we have got point A, point B, point C, and this angle is theta. So in most of the cases, the hypotenuse of the triangle will be addition of radii. Okay. So that's why radius value is given for A and B. So for A, the radius is 40 mm. For B, the radius is equal to 30 mm. So just we have to add it here, 40 plus 30. So that will be 70 mm will be the hypotenuse of this triangle. You can see the radius here plus additional radius here. Now you need to find out this length AC. The length AC is missing. So to calculate that, one more additional information is given. Total width of the channel is 120 mm. So if we able to subtract this length as well as this length from the total 120 mm length, then only we can find out this required length. So what is total length here? Total length is 120 mm minus this length. Now this length is equivalent to the radius of sphere A. Now radius of sphere A given is 40 mm. So 120 minus 40 minus final length. So this length is equal to radius of B. Radius of B is 30 mm. So here we get 120 minus 40 means 80 minus 30 means 50. So adjacent side of the theta is known and hypotenuse is known. So here we can use cos relation. So cos theta is equal to adjacent side, that is AC, which is nothing but 50. Hypotenuse is AB, which is 70. So calculate the value of theta. So for that we'll find out the cos inverse 50 by 70. So approximately we're getting the value of theta is equal to 44.41. Kindly check the values and update me in the comment box if anything else is required here. Okay. So first we'll draw the proper diagram because this is confusing. So we'll take the screenshot of this figure and we'll utilize it here to find out to draw the proper figure. Okay. So we'll adjust it, this figure here. Okay, perfect. So the angle is 44. So we'll start by drawing the line diagram for A. Okay. So for that first we'll draw a simple line here, one more line here, then one more line here, and one more line here. So this will represent, first one represent joint A or sphere A, this will represent joint B or sphere B. Okay. So we'll show the force. First force is acting here is R1. So we'll show it with the help of horizontal line. So this is R1. We can give the name of R1 here. This is okay, just a R1. Then the next one is a weight force here. So weight force always act in the downward direction. Show the weight force. Always show the arrow for the weight force. The value of weight force is 500 Newton. So put the value here. Now there is a weight force here, also reaction here. So I will draw the reaction as it is to avoid the confusion. Then we'll see what we can do. So this is the reaction force which is acting here. The name of the reaction force is R2. Then the R3. R3 is pointed towards the center, right? So this is your R3 pointed towards the center. The name of the reaction is R3. Angle of the reaction with the horizontal is theta. So that is nothing but 44.41. So we mark that 44.41 degree. So after with this, we'll draw for the sphere B. As always, show the weight force first. So this is the weight force. The value of weight force is 200 Newton. Mark here 200 Newton. Then this reaction. So we'll mark the reaction here. Reaction force indicated by R4. Show the arrow. Give the name R4 here. And there is a reaction here R3. So see, point or force is directed toward the center. So show the R3 reaction. Okay. So this is your R3. Now, what is the angle of R3 with the horizontal? So it will be equal to 44.41. Once we have identified the angle of R3 with the horizontal is 44.41, it will remain 44.41 with the horizontal. You don't need to worry about it. Now we'll rearrange this diagram as per our likes. So we'll refine it. So I will draw it here. We'll use the black color. So this is for the first one. This is for the second one. Okay, we'll use the red color as well. Now see R1, see the arrow. We can transfer this force in this direction. So as per the principle of transmissibility, we can transfer the force along its line of action, right? So this is the line of action. So we can transfer this R1 force along its line of action. So R1 goes here and show the arrow. This is your R1. Then this R2, transfer it along its line of action. So R2 goes up This is R2. With R3, see the direction, we can move it to the third quadrant. So R3 goes here. We'll give the name R3. Angle of R3 will remain same, 44.41 with the x-axis. Okay, and the remaining is the weight force. So show the weight force here. It is a vertical force. Sorry for my drawing. This is 500 Newton. So this will be your joint A. Now go to the joint B. This is the joint B. First show the weight force of 200 Newton. So weight force acting in the downward direction is 200 Newton. Show the arrow. Put the value here, 200 Newton. Then the reaction force R4 will be shifted here. So this is R4. Put the name R4 here. And R3 will be shifted in this direction. This will be your R3. Angle of R3 will be same, 44.41. Don't worry, don't think about opposite angle all. Every time it will remain 44.41. Okay, so we'll have here figure A and figure B. So if you see these two figures, then we can easily say that figure B has two unknown, R4 and R3, whereas figure A has R2, R1 and R3, three unknowns. And we have got only two equations of equilibrium, that is conditions of equilibrium, summation of fx0, summation of fy0. So better we can start with the joint B. So here we'll write, considering joint B and applying COE, conditions of equilibrium. So we'll apply the conditions of equilibrium, right? So we'll start with the first equation. Summation of Fy is equal to 0. You can apply anyone at the first, either summation Fx or summation Fy. So this equation becomes R3 lies in the first quadrant, angle is 44. So R3 sine 44.41. Next vertical force, R4 is not a vertical, neglect it, minus 200. So equal to 0. So your R3 sine 44.41 is equal to 200. So R3 is equal to, just divide this 200 by sine 44.41. So we get the value of R3 is equal to 285.8 Newton. Okay, we get this answer. So after getting this answer, we'll apply the second equation. The second equation here I will write, second equation is summation of Fx is equal to 0. So for R3, Fx value will be, R3 value is already known, so we can write 285.8 cos 44.41. Then R4 pointed towards left, so minus R4, so it is equal to 0. For this horizontal component is 0, so R4 is equal to 285.8 cos 44.41. So the value of R4 will be, do the calculation, 204.16 Newton will be the value of R4. Getting? So this way we have calculated the reaction forces for joint B. Now we'll focus on joint A. So we'll use the screenshot of this joint and we'll paste it here. Just rearrange it. Okay. Now we have the value of R3 is already calculated. The R3 is equal to 285.8. So we can utilize this value because the R3 value is also required here. It is same. So we can use this value and we will find out. So first we'll use the condition of equilibrium, that is summation of Fy is equal to 0. Okay. So summation of Fy for R1, there is no vertical component. R2 is present. It is upward, so positive. Then this R3 lies in the third quadrant. So it is negative. 285.8 value is known. Then sine 44.41 is the angle. Then minus 500. Equated to 0. So find out the value of R2. R2 is equal to 285 sine 44.41 plus 500. So do the calculation, find the value of R2. So as per my calculation, it is around 700 Newton. You can cross check the values. So this is the value of R2. To get the next value, we'll use the second equation. Summation of Fx is equal to 0. Now what are the horizontal components here? R1. Then for R2, horizontal component is 0. For R3, it is minus, value of R3 is known, 285.8. Use that value, cos 44.41. Then for 500, horizontal component is 0. So simply R1 is equal to 285.8 cos 44.41. The value of R1 is equal to 204.16 Newton. So that will complete the solution of this question. Okay, so first you need to identify what are the reactions, what are the weight force present in the figure. So I will give you the simple tricks for that. So weight force is always vertical force act in the downward direction. The reaction force, to draw the reaction force, we need to draw a line perpendicular to the surface in contact, and then the angle of that reaction will be 90 minus angle of the surface. If the surface is horizontal, reaction is vertical. If the surface is vertical, reaction is horizontal. And if the surface is inclined, reaction is inclined. So use this trick to master the techniques, master the problems in the mechanics. I hope you like this video. If you find this video helpful, like it, subscribe it, and share it with your friends. Thank you. Thank you very much.